Hi everyone. I'm going to go ahead and go over number 19 from chapter 4. This was one that a lot of you struggled with in the problem set that you noted in when you submitted your work. So I just want to go through it. So this is the spider question. It has two parts. The first part says calculate the tension in a vertical strand of spider web if a spider with a mass of 8.00 times 10 to the -5 kilograms, because spiders are little, not massive, hangs motionless on it. Okay, so we've got our spider, and his mass times gravity is pulling, times acceleration due to gravity is pulling down on him, right? And then we know that he's on a vertical string with T. You can just write it as capital T, or you can write it as F sub T for the force from tension is okay too. I'm going to use T because that's what they use in your book. But I know that some of the other resources use different notation. So another key piece of information is that we know that this spider is motionless. And that means that our net force is 0. And so that's going to come up on a lot of these problems, and that's super important. Sometimes you'll just know that one component is 0. Sometimes you'll know that both components are 0. And usually that's the key to solving the problem. Okay, so what that means is that if we look at the sum of the forces in the y direction, we would be able to say that we have tension going in one direction minus mg going in the other direction, and that equals 0. So that means that we can say that T equals mg. And so we can say T equals 8 to the -5 times 9.8. And that's going to equal 7.84 times 10 to the -4th newtons. So that's the tension. Okay. Now, this was the part that most of you had trouble with, which makes sense. This is a much trickier part, part B. So part B says, calculate the tension in a horizontal strand of spider web if the spider sits motionless in the middle of it, much like the tightrope walker in figure 4.17. The strand sags at an angle of 12 degrees below the horizontal. Compare this with the tension in the vertical strand. Okay, so first we're just going to find it. Then we'll worry about the comparing piece at the end. So we've got, here's our strand that he's hanging from. So here's our spider hanging at this point here where we're drawing our free body diagram, and that's mg. And then we have this tension and this tension. And then we know that this is 12 degrees and this is 12 degrees. Once again, he's motionless, right? Which means our the sum of our forces is 0. And we know that these tensions are equal to each other, right? Because he's in the middle of it. And it's sagging the same amount on both sides. And it's really nice to have them be equal to each other. Okay, so now what we need to do is look at our forces in the y direction again. So we know once again that this whole thing is going to equal 0, right? Because there's no motion. So when we look at our forces in the y direction, we see that we need to look at the y component of this one and the y component of this one, which are going to be the same thing, right? Because they're the same. So we're going to end up with T, and then this y component is opposite. So that's going to be sine of 12 degrees. Then we have plus T sine of 12 degrees for the other one, minus mg equals 0. So then we would get 2T sine of 12 degrees equals mg, we can solve that for t by dividing by 2 sine of 12 degrees. And we get that t equals mg over 2 sine of 12 degrees. So that would give us, where's this mass, 8 to the negative 5 times 9.8 divided by 2 divided by sine of 12 equals, and that gives us the tension is 1.89 times 10 to the negative 3 newtons. So this is the tension in each of these sides here. Okay, so that's the tension in the whatever it's called, spider webbing. And then we want to compare them. So we can do 1.89 times 10 to the negative 3 divided by 7.84 times 10 to the negative 4 newtons, and this is T horizontal over T vertical. 1.89 to the negative 3 divided by 7.84 to the negative 4, and that equals the horizontal tension is 2.41 times greater than the vertical tension. Okay, so that is that problem. So hopefully this helps. I know you all worked really hard and many of you had gotten kind of a basic understanding of this problem just by using your perseverance to get through it, but hopefully this helps clear it up even better. And let me know if you have any other questions. Thank you.